All right, here we go. So what I want to do, first of all, the first part of this worksheet, actually 2/3 of the worksheet are just simplifying radicals, okay? And the reason that I'm showing you this, I just want to make sure. How about this? I will do all of the evens or odds. Okay, you can copy them down, and then if you still feel like you didn't get the assignment, you can do the other ones over if you want to. Is that fair enough? Okay. So what should we do? Evens or odds? Jackson? Odds. Okay. So let's start with number 1. Okay. All this is radical operations, and we're continuing. I'm sorry, what was that? Oh, I thought you said something, Levi. Okay. So we've got the square root of 75. Okay. Now, again, there are lots of different ways. Well, okay, I say lots. There's really 2 different ways you can go about this. Okay. I can just list 2 factors of 75. Okay. Are you guys writing this down? Are you guys paying attention? Are you looking at the board? Okay. Or I can simply start simplifying this down to all of my prime factors. It doesn't matter. Okay. I know that 75 ends in a what? In a 5. So therefore I know it's divisible by what? By 5. Okay. I can start there. Okay. Does anybody know what 5 times what is 75? Huh? 15. Okay. I can start right here. Okay. Can I simplify 5 any further? No. Can I simplify 15 further? Yes. Give me some factors of 15. 3 and 5. Jackson, you have a question? I know. I'm just showing you different ways, okay? If I do it this way, okay, every time I have a number that repeats, I can't simplify these any further, can I? Okay? Anytime I have a number that occurs twice. Do I have one that occurs twice? Okay. You can circle them because I know that number, whatever it is, what's in the radical sign there? What's in the radical sign? What's in the radical sign on the ones that I circled? 5. Okay, and I have 2 of them, so I'm going to remove that. Okay. This, what is the number? It's a 5. This goes outside. Okay. I have eliminated this, and I have eliminated this. Right? What's the only thing left down here? Okay. Can I simplify this any further? No. Okay. And if I want to check my answer to see if I'm right, okay, if I have a number outside the radical sign, okay, I can, if I was to, what's 5 times 5? What's 5 squared? And times the number inside the radical. What is that? What's 25 times 3? Is that the same thing as what I have here? Yes. Now, Jackson said I did it a different way, and that's fine. Okay. If you were to do this, I know 25 times 3 is 75, right? So I could have done 25 and 3. Okay, can I do anything with 3? Can I find the square root of 25? And what is that? Okay, so that 5 goes on the outside. This is gone. What's the only thing left inside? Is that the same answer? Yes. Question?
I did this different, but I got the same answer.
Okay.
So,
Yes.
my mom was like doing this weird thing with exponents. She's like, you have to make an exponent before you take it out. And we got the same answer.
It's like it's basically making an exponent of 2, right?
Yeah.
Squaring it. Okay, it's the same kind of thing. Okay. Let's look at another one. Let's look at number 3. Okay. All right, number 3. I've got the square root of 175. Okay. First of all, this ends in a what? 5. Okay, so I know it's divisible by what? By 5. Does anybody know 5 times what? 5 times 35? Is that right? 5 times 25? 5 times 25 would be 125. 5 times 35. Okay. So if I do 5 times 35, okay? Is this one, am I good here? I can't do anything with this one. Give me some factors of 35. Okay. Can I go any further on either of these? No. Do I have any that repeat? Which is the same as 5 squared, right? 5, what stays inside the radical sign? What's all that's left? Okay, can I go any further than that? No. Okay. Did you write this stuff down? Okay. Question.
How do you figure out, like, what everything is? Like, how did you figure out what 35 is? It's like a list?
You just divide it. If it ends in a 5, you know it's divisible by 5.
Yeah.
Okay, so you can use a calculator to say 175 divided by 5 is 35.
Oh, I didn't know.
Okay. Yes.
So if you have the same numbers left over, like 5 and 5, you put that as the perfect square number.
It is the perfect square number. Yep. Okay. All right. Let's try another one. Let's look at number 5. I have the square root of 392. What's the first thing you guys should look at to see if this number is a perfect square? Is 392 a perfect square? It is not. Okay. Now, big numbers like this, you can do this 2 different ways. Okay. The way that I like to start with big numbers like this, you can start dividing it by perfect squares if you want to. Okay. But what I like to do, if I know that it's divisible by 2, do I know it's divisible by 2? How do I know that? Because it's even, right? So then I have 196. Now, I've already gotten rid of I haven't gotten rid of anything yet, but if I look at these two numbers, okay, is 2 a perfect square? No. Can I do anything else with that? No. Is 196 a perfect square? Yes, it is. What is that? What is the square root of 196? 14. So I can say, if I remove this, I have a 14, because 14 times 14 is 196, isn't it? And what's left inside the radical?
2.
What's left? 2. Now, what if you didn't know that 196 was a perfect square? I can still do this, okay? What's 196 divided by 2? 98. Can I keep going? 98 divided by 2 is what? Now, do you recognize 49 as a perfect square? Okay. So, if I have a perfect square, what times what is 49? What times what is 49? 7. So I've got a 7 outside. Okay. Do I have any other numbers that repeat? I have 3 2s here. Is there a 2 of any of them? There's 1, 2. So now if I have 2 of them, what is removed and taken outside the radical sign? A 2. What's the only thing left inside there? A 2. What's 7 times 2? Okay, did I get the same answer? Yes, I did. Christy.
I've gotten all of them right except on one of them that I switched them so the 2 was on the outside and the 14 was on the inside.
Yeah, that means something different, though. Okay.
So when it has to be the pairs that go on the outside.
Mm-hmm. Unless it's a perfect square inside here, like this 49, it automatically removes it. Because if I was to do this, if I was to go further on this, this would be this. And I would have 2 of these, so they remove.
Okay, so it's kind of just like whatever's left over when you multiply them, you just put it.
That you can't factor any perfect squares out. Okay. Jackson.
I did 8 and 49, but I got 7 and
You did what?
8. I got 8 and 7 and, well, I got 8 and 49, but it got 7 and 8.
What? I got 8 and 49 and I got 49.
You had 392 divided by 49 is what? 8? Okay, look. So if you did this, 8 and 49, okay, this is gone, right? So that means 7. But I can factor this further, right? What is this? 2 and 4. Are either one of these a perfect square? What's square root of 4? 2. So that comes out. What's the only thing left? Okay, which would give me the same exact answer. Okay. All right. Okay, is this helping at all? Okay, let's try another one. Okay, let's look at number 7. Okay, number 7. I've got radical 24. Well, this one's pretty easy, right? Just give me some factors.
4 and 6.
4 and 6. Are either of these a perfect square? Which one? 4. So what happens what's the square root of 4?
2.
So the 2 is outside now, right? What's left inside? Now, I can factor 6, but are any of the factors of 6
Square roots.
perfect squares? No. Okay? So what's left inside the radical? 2 radical 6. Okay? Does that make sense? Okay? All right. Let's look at number 9. Okay, number 9 was a little trickier. I have -8 radical 245 r to the 4th. Okay. So first thing, I'm not going to do anything with this -8, right? I'm just going to leave that out there, okay? So this -8, we'll put parentheses around it so we know it's separated. Now, what do I know for sure that 245 is divisible by? 5, right? And if I divide that on my calculator, if you divide 245 by 5, tell me what you get. Can I go any further with 5? No. Can I go any further with 49? What's the square root of 49? So what goes outside? Times 7. What's the only thing left in there? A 5. R what? R to the 4th. Okay. So we're done with this number, right? We're good there. Agreed? But now, what does this R to the 4th mean? That means R times what? And every time I have 2 of them, it removes 1, right? So do I have 2 of these? So what comes outside? So -8 times 7 times R. I have 2 more. What comes outside? Times R. What's the only thing left inside? This is all gone. This is gone. This is gone. This is gone. Gone. A 5. Okay, what's -8 times 7? -56. What's R times R? R to the 2nd. What's left inside the radical? 5. Okay, that's it. Okay, copy that down if you didn't. How many of you got that one right? Good. Good. Okay? Are you with me so far? Okay, let's continue. Let's look at number 11. Okay, I have 4 and then radical 200 x to the 2nd. Okay? That 4 is just going to stay out there, right? Right? Okay, let's deal with the 200. Give me some factors of 200. Okay, now I would do 2 and 100. Now you can keep going here if you want to. I don't care, but if I recognize one of those as a perfect square, is 100 a perfect square?
Yes.
What's the square root of 100? 10. So what is removed here? 10. Okay, what's left inside the radical? This is gone. Just 2, right? And I have x times x, right? Well, every time I have 2 variables, what happens to it? Goes outside, right? Okay, so now this is gone. I have 4 times, oops, I don't know why I read her 2 and I said 4. I have 4 times 10 times x. What's inside the radical? 2. What's 4 times 10? 40. X radical 2. How many of you got that one right?
I got that
Okay.
right.
But if you missed it, do you see how we got that right? It's not that difficult, is it? Okay. Let's look now at number 13. Okay. So I've got -2 radical 48 m to the 4th. Okay. Am I doing anything with -2 yet? No. Okay. Well, give me some factors of 48.
4 and 12.
What'd you say?
4 and 12.
4 and 12, okay. Are either of these a perfect square?
Yes.
4 is, right? What's the square root of 4?
2.
So this one's gone. I put that 2 out there. Okay, can I factor 12? Give me some factors of 12. 3 and 4, okay. Are either of these a perfect square? Which one? 4, so I can remove that, right? What's the square root of 4? 2. I'm going to move this down here. I have -2 times 2 times 2. What's the only thing left in there? This and m to the what? Okay, which means m times m times m times m, right? Every time I have 2 m's, what goes outside? 1 m, right? So that's gone, that's gone. I have negative 2 times 2 times 2 times m, but I have another 2m, so that goes outside, right? And what's the only thing? All of this, bless you, what's left inside that radical? 3. Okay, what's negative 2 times 2? Negative 4 times 2? Negative 8. What's m times m? M to the second. What's inside? 3. Okay. How many of you got that one right? Well, not as many of you. Okay.
4 m to the second.
Okay. Do you see why this answer is what it is? Okay. Is this starting to make sense to you guys? Okay. Let's look at number 15. I have 6 radical 48x. Okay? Am I doing anything with the 6? Okay. Are there some factors of 48 I can use? Give me some factors of 48.
3 and 16.
3 and 16. Are either one of these a perfect square?
Yes.
Which one?
16.
What's square root of 16?
4.
Okay. What's left in there?
48.
3 and what?
Oh, 3 and x.
X. I can't simplify this any further, can I? What's 6 times 4?
24.
24 radical what? 3x, okay? But let me tell you this, because sometimes if I do this same problem over here, I may not know. Sometimes you guys don't really know your multiples of 16, right? So if I had done, let me just show you. If let's say I did what, maybe 4 and 6, is that also, does that work?
No.
Why? I'm sorry. 4 and 12. Does that work?
Yes.
Because first of all, what is either one of these a perfect square?
Yes.
4 is, right? So what's the square root of 4? 2. Okay. Can I do 12? What are some factors of 12? 4 and 3. Is either one of these a perfect square? What's square root of 4?
4 and 2.
2. Okay. What's the only thing left inside there? A 3 and an x, right? So 6 times 2 is 12 times 2 is what? 24 radical 3x. So those are the same answers. Okay? All right. How many of you got that one right? How many of you missed it? Okay, do you see where you went wrong? Okay? All right. Let's look now at number 17. Okay, so 17, I've got negative 2 radical 27 plus 3 radical 3. In order to add these two, what do I have to have? A common number inside the radical, right? Okay. I can't simplify this any further. So this is going to have to simplify to this, isn't it? Can I do anything with this? I'm just going to leave it, right? So plus 3 to the third. This has to have what inside in order for me to add it to this? Everybody.
3.
A 3. Okay, so give me some factors of 27. If I do 9 and 3, okay, are either one of these a perfect square? Okay, so I have negative 2 times, what's the square root of 9? 3. What's left inside there? What's negative 2 times 3?
Negative 6.
Negative 6 radical 3 plus 3 radical 3. So no matter what, my answer is going to be radical 3, right? It's like a denominator. Okay, what's negative 6 plus 3?
Oh, negative 9.
Negative what?
9.
Negative 3
Oh, yeah.
radical 3. Okay.
Hold up. What? Oh, that's negative.
Yeah, negative. You owe me 6, you have 3.
Oh.
Okay, how many of you got that one right? Most of you got that right. Okay, good. Let's look at number 19. Okay, I got negative 3 radical 5 plus 3 radical 45. Okay, are either one of these simplified inside?
5.
The 5 is. I can't do anything with that. So in order to add this to this has to have what inside?
5.
A 5. So I'm going to bring this one down. So negative 3 radical 5 plus, give me some factors of 45. 9 and 5. Okay, are either of these perfect squares? What's square root of 9? So this is now 3 times 3. What's the only thing left inside there? So now we're in good shape. We just got to simplify this, right? Negative 3 radical 5 plus, what's 3 times 3? 9 radical 5. So I know my answer is going to be what? Something radical 5. What is negative 3 plus? Now you owe me 3, but you have 9.
-6.
Positive 6. 6 radical 5. Okay, does that make sense?
Yes.
All right, last one. Number 21. All right, I have 2 radical 27. And I have 3 radical 3. Okay, God bless you. Okay, either one of these simplified? This one is, right? Okay, so this is going to stay like this. I need to get a 3 in here. Give me some factors of 27. 9 and 3. Let's square root of 9. Square root of 9. 3 radical 3. What's 2 times 3?
6.
So 6 radical 3 plus 3 radical 3.
Equals 9 radical 3.
6 plus 3 is 9 radical 3.
Yay.
Okay? All right.
We should do, what was the one that we made? Oh, we should do number 22 too.
We should do number 22 too? Okay, I'll do number 22.
We had to do both.
You had to do them both. Okay. Number 22. 3 radical 27 plus 2 radical 12. Okay. Let's simplify both. Let's start with the first one. Okay. Give me some factors of 27. This is getting old. These are the same ones every time, huh? Radical 9 and radical what? Okay, are either of these a perfect square? Yes?
I feel like the way I do it, it helps if you put the lower number with like then
Like that?
yeah.
Okay.
'Cause then you can like circle.
That's fine. Okay, so I got a 3 out here. Can I find the square root of 3?
No.
No. Can I find the square root of 9? What's the square root of 9? 3. So 3 is out here. What's all that's left inside?
3.
Okay. Now let's do this one. Give me some factors of 12. Okay. Is 4 a perfect square? Yeah. So this is 2. What's the square root of 4? 2 radical 3. Okay. I'm in good shape because, thank you, I have radical 3 inside, right?
9 radical 3.
What's 3 times 3?
9.
9 radical 3 plus 2 times 2 is
4.
4 radical 3. I'm in good shape because I have a common number inside my radical, right? What's 9 plus 4?
15. I mean 13.
13 radical 3.
I added that.
How many of you got that one right?
Wait.
How many of you missed that one?
I added.
Okay.
Yeah, I have it wrong too.
Smear.
Can I do number 18?
How do I do number 18? You need to simplify 2 radical 8 down so it has a 2 inside.
I said, can you do number 18?
Okay, but I'm telling you, this is the same as all the other ones we've done. Okay? You have 2 radical 8 plus 3 radical 2. Okay. Smear, is this simplified already, this one?
Yeah.
Yeah, so let's bring it down. That tells me that what has to be inside this one in order for me to continue? A 2, right?
Yeah.
Give me some factors of 8.
4 and 2.
Okay? Can I find square root of 4?
Yeah.
What is it?
2.
What's left inside?
2.
2. What's 2 times 2?
4.
4 radical 2 plus 3 radical 2. My answer is going to be radical 2. What's 4 plus 3? 7. Okay? Make sense? Okay. If you need, how many of you need some more time on this to finish it? Okay, take some more time. Okay, otherwise, pass them up to Jane. Okay, make sure your number's on it. Make sure your name is on it, please. Okay. Then take out your notes, and I'm going to show you today's lesson. It's super duper easy. Hurry, hurry. Let's go. Thank you. Okay. So, as I mentioned, today's lesson is pretty easy. Part of what we're doing today is review. Okay. All we're doing. Okay. We're not going to do operations with roots today. Okay. We're going to look at square roots a little bit differently. Okay. What do I mean by that? Well, all right. First of all, by the way, if you guys go online to look at this, it's all going to be part of one lesson, okay? So you may have to fast forward over this video. But today's lesson is easy. Okay, let's review real quick. If I have something like this and I have a perfect square, what's the answer to this? This is the square root of
4.
the square root of 16 is what? 4. What if I have a negative sign in front of the radical? What does that mean? The negative square root of something is, this would be negative 4, right? Okay. Now, I can't have a negative sign inside the radical sign. Does anybody remember why? Can you multiply any two numbers times themselves and ever get a negative?
No.
You can't. It's impossible, right? Because negative 4 times negative 4 would be what? Positive 16. 4 times 4 is what? Positive 16, okay? So you can't have a negative sign inside the radical sign. What if I have a fraction? Okay? What if I have this? What's the square root? How do I deal with a fraction like this? Anybody remember? I look at each number and see if they're what? A perfect square. Is 4 a perfect square?
Yeah.
What's square root of 4?
2,
What's square root of 9?
3.
3. Make sense? You remember doing that? Okay. What if I have this? I'm not going to change it. This says the negative square root of 16 over 25. What is the negative square root? It's going to stay negative. What's the square root of 16? 4. What's the square root of 25? Okay, now I can't simplify either one of these fractions, right? But if I could, would I? Yes. Okay. Are you with me so far?
Yes.
Okay. What if I have something like this? Negative 0.4. Okay. Do you think, now here's the thing. If that decimal wasn't there, this would be a 4. A 4 is a perfect square, right? But when you have a decimal, it's very, very important that you see where the decimal is placed. In other words, this is not the same thing as this. Okay? Try this. Try 0.4. Try to find the square root of 0.4 in your calculator. Tell me what you get. Jackson, did you try it? What did you get? Huh? Do that again. Do square root of 0.4. Not 0.04. 0.4. No. Okay, listen, guys. Do 0.4 and then press your square root button.
Oh, 0.4 then? 0.6.
That is 0.6322455553 This is going to keep going, okay? And here's the reason why. Because this decimal placement is important, okay? Yes. This decimal placement is important because, okay, anytime you multiply, if you do this one, do 0.04, tell me what you get. Negative 0.2, right? Okay. Here's why. You have two decimal places to account for. Anytime I multiply a number with a decimal, let's just say it's one decimal place. If I had this, 0.2 times 0.2, how many decimal places am I going to have to account for here? 2, okay? Do you understand why this is not the same as this? Your decimal placement is important. Okay. All right, are we good on that? Okay. Last thing, I'm almost done. Okay, is this the same as this? No matter what, this 16 is what? Are you looking up here?
4.
You should be copying this down. Square root of 16 is 4. This is the only answer for this. But what does this mean? This means some number, what?
The second problem.
Some number squared equals 16, right? So what does x equal? Do you think there's only one answer here? Well, if x is 4, but what else could x also be? No, 2. If I put 2 in the place, that's 4. What can I replace x with that will equal 16? 4. What else?
No, because
If I put 8 in there, it's 64. Don't be so positive. Don't be so positive. Yes, if I put a negative 4, okay, this is not the same as this, okay? This specifies this is positive. This specifies that it is a negative square root. This tells me when I see a variable squared, it will have two answers. Because could it be 4? If I put in place of this, does that equal 16? If I did this, does that also equal 16? Yes, it does. Okay? Does that make sense? Okay, you're going to see something like that on your worksheet. All right. That's all I got.